Welcome to Frontline Systems webinar on an overview of optimization applications in Excel using our advanced products. My name is Dr. Sima Maliki. I'm Consulting Lead and Modeling Specialist at Frontline Solvers. During the presentation, if you have any questions or comments, please type them into the chat box to be answered as time allows. I strive to remain within the promised 30 minutes, yet to thoroughly cover all the material, sometimes it takes a few minutes longer. I very much appreciate your cooperation. As we all know, the optimization applications are widely used across many industries and functional areas. We would like you to know that many of our customers have found optimal solutions for their industrial problems worth millions in savings, as building a model can give you insights and a money-saving optimal solution. Today, we explore how optimization can benefit you in solving your business problems and how easy it is to use our tools to solve them. Together, we'll review typical applications in transportation, inventory management, financial services, scheduling staff, and one example of automating optimization using VBA. Maybe you wonder what solvers are good for. So let's start talking about the decision-making process and using optimization to solve a problem. It is always best and most powerful to efficiently allocate scarce resources arising in your business. It can be money, equipment, staff time, transportation fleet, and raw materials inventory. All of these are resources and they are allocated for some purpose. Deciding on which products to ship from factories to warehouses along each route is an allocation of products to routes. Portfolio optimization is allocating money to stocks in a portfolio, and scheduling is really a matter of allocating people to time slots or scheduling the availability of hospital operating rooms. Solvers or optimizers are software tools that help you determine the best way to allocate those resources. You might be wondering what you need to do to use a solver or how to define your optimization model. Let's drill down on this further. There are three main steps. Each optimization problem involves one or more decisions that must be made in order to solve the problem. The decision variables are typically numbers reflecting how much of some scarce resource is being allocated to some use or purpose, and that is normally under your control. These decisions need to be made in the best possible way while simultaneously satisfying a number of logical conditions or constraints. Constraints reflect the physical situations. There are various types of these constraints. Some of the constraints represent limits on available resources such as inventory or money. There are constraints that reflect the physical situation. One of them is non-negativity on variables. You can't produce a negative number of products, or you cannot assign a negative number of people to tasks. Some constraints are determined by policies that you or your organization may set. For example, in a portfolio optimization, you might have a limit on the maximum percentage of funds to be invested in any one stock or one industry group. Then you might have balance constraints. For example, warehouses are temporary holding points. Therefore, flow out from one warehouse is equal to its flow in. They have an equality form, or the beginning inventory of this cycle equals the ending inventory of last cycle. And another common element in each optimization problem is the existence of some goal or objective that the decision maker considers when deciding which course of action is best. You can determine objective function by asking what measures are we trying to optimize. The best or optimal solution might mean maximizing profits, minimizing costs, or achieving the best possible quality. Now it is time to dive in and see how we can solve a problem in practice. Transportation and logistic operations of your company can be a competitive differentiator. So let's find out in this example how optimization can be used to optimize a transportation operation. This company has 3 different goods that have to be shipped from 2 factories to 4 warehouses, and from those warehouses to the 5 customers, or directly from factories to customers with minimum cost. Here's a diagram of the system with nodes for factories, warehouses, and customers. Now we need to show the supply-demand pairs displaying feasible routes for the shipment plan. These gold color arrows show the potential flows from factories to warehouses and customers. And then these green arrows show the potential flows from warehouses to customers. Now let's take a look at the Excel workbook. Okay. This is the full analytics solver platform ribbon, which includes optimization, simulation, and data mining. Today, we are going to focus on a subset of ASP called Premium Solver Platform, so we can change the product. And when you're using a free trial of our software, you can also do this yourself. To do this, click on Help, click on Change Product. Here, let's choose Premium Solver Platform, and then click OK. Okay, now we only have access to optimization. Let's skim through the Premium Solver Platform ribbon together. As you can see, clicking on this Model tab displays or hides the task pane. And in this drop-down list, there are additional options for multidimensional modeling that are beyond the scope of this session. Then, Optimization Model tab allows you to set up optimization models. This includes decisions, constraints, and objectives, which we will practice to use them today. Parameter tab provides the options to run multiple parameterized optimization. In the Solve Action tab, you can solve your optimization models. Then in the Analysis tab, you can analyze the results, create reports, and charts. Tools tab enables you to examine optimization results. There's this Publish button that allows you to publish your models for use and distribution on the web. This includes Excel Online and Google Sheets. And we also have apps for both of these. Let's explore the Help tab. Here you can display online help, use live chat, control guided mode, which we will discuss in more detail today, open examples or an online tutorial, access user and reference guides, and check your license status and more. Okay, back to this Model tab. So clicking on this Model tab displays or hides the task pane. So let's check the task pane together. The first one is Model tab. This allows you to view the model in outline form. You can see the results of model diagnosis and optionally edit model elements in place. Next is Platform tab. Here you can view or change the platform options. This includes number of optimizations to run, the default bounds on decisions or uncertain variables, and so on. Then we have the Engine tab. Here you can select a solver engine and set its options. Options are available below. And finally, we have the Output tab that allows you to view a log of solution messages or a chart of the objective values. Now let's go back to our example. I want to have it on the Model tab. Let me increase the size of this Excel. Okay. As you can see in this Excel workbook, the cost of shipping from factories to warehouses, factories to customers, and warehouses to customers are recorded in these cells. These are inputs to the problem that are not under our control. These shipping costs are coded to us by our outside shipping company, for example. So we need to reserve cells for variables representing quantity shipped from factories to warehouses, factories to customers directly, and from warehouses to customers. This is how we define decision variables. As you can see here in the Model tab of the task pane, 3 sets of variables are defined. What measure are we trying to optimize? Each route of flow incurs a cost. There are 2 goals that need to be carefully addressed in this problem: the total costs and service. We want to provide the service with minimum cost and ensure that each customer demand is completely satisfied. So, the objective function is minimization of total cost of shipment along all the routes. Our objective function is total cost, and it is defined in cell C91. So let's scroll down to C91 now, and you can see the formula here. To calculate total cost of shipping from factories to warehouses, since the cost coefficient for these routes are defined in cells C10 through F15, we need to multiply these by the total amount of product that will be determined to be shipped. This is the first component of this sum product function, that is adding all the shipping costs together. So C41 through F46 are our decision variables, and then C10 through F15 are the cost coefficients for those specific routes. And then similarly, we have the other cost components. So let's go back to constraints. What restrictions limit our choice of decision variables? The capacity of each warehouse, supplies available from each factory, and the demand from each customer need to be considered. So first one is warehouse capacity constraints. We want to make sure that what we ship into the warehouses doesn't exceed the capacity of those warehouses. We cannot overload warehouses, as each one has a physical capacity. Let me close this. Okay, next one. We have a certain supply available at each factory provided in cell H63 through H68. The total flow out of factory 1 for each product type must be smaller than or equal to the factory supply. This is same for factory 2. Then we need to ensure that each customer product demand is satisfied. Here are these constraints. Total to customer should be greater than or equal to the customer demand. Warehouses are temporary holding points. Therefore, flow out from one warehouse is equal to its flow in. These type of constraints are called balance constraints, and they have an equality form. For now, let's go ahead and click on Optimize to solve this model. This time, we are going to step our way through guided mode and see what it can tell us. This feature is a guide offering help for you in each step of your modeling efforts, preventing common errors. click continue. Two things happen here. First, solver has analyzed all the formulas in the model and determined the structure of our model automatically. Because the right solver engine wasn't selected, it is letting us know and giving us other choices. So I'm going to choose the first engine that is recommended and then click on next step. Here, guided mode is telling us that solver found the solution, all constraints and optimality conditions are satisfied. Now click on OK, and here are the results. We achieved what we wanted, which was to determine how best to ship products between the factories and warehouses and customers, so to minimize our shipping cost, which is now $519,700. And then, of course, if you don't want to use after a while that you're used to using guided mode, you can go to operating mode, click on help, operating mode, and here you have two options. We recommend you to choose auto help mode, which will only bring up the dialogues when there is a problem. Okay, so we just looked at how optimization can help us with a typical transportation problem. Now let's look at an inventory management example. Let's click on Premium Solver Platform tab. And okay. This warehouse sells 4 products with a different demand for each product. Each product has a different holding cost and requires a certain amount of space. We have a limited storage capacity. So what is the best ordering policy for a warehouse to minimize cost while meeting demands? As you might know, there is an analytical solution for this problem, which is known as economic order quantity, or EOQ. Unfortunately, this formula doesn't always work in real world. Demand usually fluctuates. Ordering time is variable, and other factors arise to further complicate the problem. In this model, we have one such factor, a limited storage space. The variables are amounts to order each month for each product. These are called quantities in this model. And by changing these variables, we change the total cost. We have the storage capacity constraint. The space used should be less than available space. And then our objective function is to minimize total cost. And this is defined in cell E17. Let's take a look at this function. This is the sum of these cells E13 through E16. And I want to show you that each of these has a function that is holding cost times average inventory level plus the cost to place an order times average number of orders. And this has happened for all of the products. This is a nonlinear problem. So let's hit the solve button or optimize. Let's click on continue. This is telling us, the guided mode telling us that this was a nonlinear programming, non-convex model. And then here are the results. So the amounts to order each month, minimizing cost, meeting demand, and without exceeding the storage space. Next, let's look at a financial services application, allocating money to stocks. And in this example, I want to actually show you how we can define the optimization model components. So we want to practice together. So let me bring this up. This is a portfolio optimization application. So the goal is to find the best combination of stocks that minimizes risk for a given return. The returns, variance, and covariance between all the stocks are known and are recorded in this workbook. I also included the formulas, and I will show you in a second. So in this problem, the variables are the percentage allocations of funds that we can invest in each stock. So let's define these decision variables using the Premium Solver platform ribbon. We can reserve cells C14 through H14 through G14 to hold the percentage allocations of funds or the decision variables. I've called them allocations. Now, click on Decisions, and you can see these allocations are defined as decision variables in the Model tab of the task pane. To define the objective, the portfolio variance, I have defined a quadratic function at cell C18. And I've used this a custom quad product function. So select this cell and then go to the ribbon, click on Objective, and use min to define C18 as a normal objective to be minimized. And you can see again that this is added in our task pane model tab. Now constraints. The first constraint is the total portfolio constraint, summing the allocations of funds to stocks, which is summing to 100% or 1. So we need to set up one cell in the spreadsheet to represent the formulas of this constraint. Here I use cell H14, and you can see it is just a sum over all allocations. So select this cell, H14, and then click on Constraints button, and let's choose Constraints and the middle one, which is Equality. So H14 is now our constraint left-hand side. In this Add Constraint dialog, now we can enter either 1 or 100%. Just enter it manually and click OK. Now, the second constraint is total portfolio return, which is sum product of allocations and stock returns. And this might be greater than 9.5%, for example. And to add this constraint, we need to set up one cell in the spreadsheet to represent the formula of this constraint. Here I have used cell C20. So you can see it's the sum product of portfolios and expected return. So let's select this cell C20 and click on Constraints, Constraints again, and then this time let's choose greater than or equal to. Now on the right hand side we need to enter 9.5% and click OK, and this constraint will be added. Okay, let's click on Optimize to solve this problem. Let's click on Continue. This is a quadratic programming convex model and solver-friendly solution. These allocations of funds to different stocks results in the minimum risk or minimum variance portfolio, and it achieves 9.5% return. This is often called an efficient portfolio. You may have heard of efficient frontier. Using Premium Solver platform, we can construct that efficient frontier rather easily, and I want to show you how. So far in our example, we have used the solver and found the optimal portfolio with minimum variance for a given target rate of return of 9.5%. Now we want to generalize that. And we want to use parametric optimization to find the efficient frontier that is the optimal solution for several levels of portfolio return. To do this, let's choose an empty cell, for example, D20. Then click on Parameters, then Optimization. Now we want to insert a parameter. This dialog box has, in the lower part of it, let's enter 8%. And in the upper part, let's enter 14%, and that is because one of our stocks return 14%. Let's click OK. We defined the parameter. You can see D20 is added. Now we have to modify the constraint right-hand side to point to our parametric return rate. So let's click on Portfolio Return Constraints, and here on the right-hand side, instead of 9.5%, let's point to cell D20. and click OK. Next thing we need to do is to change the number of optimizations. To do this, click on Task Pane Platform tab. Here the first option is number of optimizations. Instead of 1, we want to run 10 optimizations. So let me put this on Output tab and clear the results so you can see what happens. Now if I click on Optimize, let's skip the guidance. You will see 10 optimizations are finished. And the worksheet initially displays the values for the last optimization, but we can change this to optimization 1 or any of the other optimizations in the Tools tab. Now, next thing we want to do is click on Charts, Multiple Optimizations, and let's select Monitored Cells. Here I want to select the Objective Portfolio Variance. I click on OK. This is the Efficient Frontier plot. Now let me click on this button to have the right pane. Then we want to go to click on this drop-down menu, click on Chart Options. You can see on the X coordinate, instead of optimization index, I can actually use the opt_param, the values of our parameter, which are our return threshold, and the chart gets updated. So here's the Efficient Frontier plot with the return thresholds. Okay. So we looked at this financial services application. Now, a recap on what we practiced: modeling and solving problems in Excel spreadsheets. You can reserve a cell to hold the values of each decision variable. Then pick a cell to represent the objective function and enter a formula that calculates your objective function. Then you need to pick other cells and use them to enter the formulas that calculate your left-hand side of constraints. The right-hand side of constraints can be entered as numbers in other cells, or you can enter them directly into the Solvay's Add Constraint dialog. And one quick note, it is best practice to use constants for constraint right-hand side. Constant means like this, just like single numbers. Now, let's look at a scheduling example. This example is about allocating staff. So let me open the Excel workbook for this. Let me increase the size. And okay. An amusement park needs a certain number of employees each day of week. Each employee must be on a schedule that gives him or her 2 consecutive days off. How many employees should the park hire, and what schedule should they be on to minimize total payroll cost? So, for each employee working 5 consecutive days with 2 days off, we are looking to find the schedule which meets demand from attendance levels while minimizing payroll cost. We have several possible schedules that are defined here. Then we define decision variables reflecting the number of people that we need to hire for each of these 7 possible schedules. And these decision variables, we call them employees per schedule. You can see that they have been defined as integer. We have logical constraint, the demand constraint and non-negative and integer value for number of employees. And then our objective is to minimize payroll costs. And this is defined here. Let's solve this problem by clicking on Optimize. I'm going to skip the guidance. Okay, Here are the results. The number of required people for each schedule. Now let me click on Schedule 2. This is another version of this problem. So far Park has hired the required employees. It now needs to decide which employee goes on which schedule. Each employee has given a list with his or her preferences. This is something that might happen in real world a lot. A 7 means the most desired schedule and 1 means the least desired. So the question is, how should the park divide the schedules among these employees? In this example, so let me click on Model tab. So schedules are defined here, and they are defined as binary. And then we have defined a total of a schedule for each person. Then we have a schedule per employee equal to 1. So each employee is only assigned to one schedule. And then employees scheduled have to be equal to the required employees. And then about our objective function, we have total preferences defined to be maximized. Let me show you the components of this total preference. This total preference is defined as a sum of all preferences for each specific employee. And then if I go to each preference, you can see it's a sum product of employees' preferences times the schedule assigned to that employee. So we are going to maximize the total preferences. Let me click on Optimize and skip guidance. And here is our optimal solution. In this model, we solve the problem after finding the optimal solution of previous example, which was a scheduling 1. It is also possible for you to find both solutions automatically, and you can write a VBA macro to do this. Now, it is a good time to talk about automating your models. This allows you to run your predefined solver models and control the solver. You can automatically update data, run the model and retrieve the results, and also create an application to distribute to your end users. So you can do this, automating your models, control solver engines using VBA Object-Oriented API. I want to show you one of the examples, which is about oil and gas application in a refinery. So let me open this example. And maximize. The VBA code for this model shows some of many ways you can use the object-oriented API, such as how to call the solver, how to retrieve sensitivity information from VBA, for example. So the goal is to plan the operations of refinery to maximize total profit. This oil refinery purchases 2 crude oils, and these oils are put through 4 processes: distillation, reforming, cracking, and blending to produce petrols and fuels, which are then sold. So you can see the decision variables here on the model tab. You can see the constraints, different bounds on these crudes, and then the total profit. Let me click on Developer tab, Visual Basic, to show you the macro. The first line, dim prop as new problem, creates an instance of the problem. Then we are selecting an engine, we are setting the parameters of that engine, and then we run the optimization with prop.solver.optimize. In the next lines, we are going to put a message box. And you will see that as we run the model. Then we have a for loop, and then within that we have another for loop with another message box inside it. Then We show some dual values or reduced costs, and then we show some of the shadow prices. Then with problem.solver.report, we are asking for an answer report, and you're going to see that happen. Okay, let me close this. Click on this button to run the macro. So here are the results. We get the optimization status, and then I want to quickly go through all of this. We have all the decision variables in the message boxes, and then after that we get the dual values. So you can see final values for all of them. And we have a lot of decision variables, so it's taking a little bit longer. Then we get the reduced costs. Of course, you can get the results for those desired variables. And here you can see the answer report is generated. So that was what we requested in the code. Let's go back to our PowerPoint slides. So you can access our optimization software within Analytics Solver platform or Risk Solver platform products, or you can get it as a standalone program such as Premium Solver Platform or Premium Solver Pro. Everything we saw today can be done using Premium Solver Pro or more advanced products subject to your model size. The Solver Upgrade products have very nice usability features with just limits related to your problem size, structures, and also solver engines. We allow you to add up to 8 different large-scale planning solver engines for your platform products and enable you to extend the power of those products. This makes it practical to solve very large problems, essentially only limited by memory. But you can do much more with our products. We offer a complete solution for any type of conventional and stochastic optimization problems, simulation and risk analysis, decision trees, and forecasting, data mining, and text mining. You can find optimal solutions for models with uncertainty using chance constraints, recourse decision variables, and robust optimization and stochastic programming methods. Our wide-ranging product line empowers you to perform analytics on the web and desktop spreadsheets, also web, server, and desktop applications in any scale. As we mentioned earlier, many of our customers have found optimal solutions for their industrial problems worth millions in savings. We saw today how building a model can give you insights as well as a money-saving optimal solution. We offer powerful tools to help you get a better solution by automatically diagnosing your model structure, fixing problems for you, selecting the right solver engine, and providing updated information at each step. Today we just explored one of these features, the guided mode, that helped us choose the right engine. You might be asking, what is the next best step to begin? Please register at our website for free. This allows you to access our downloadable user guides, more than 40 example models like the ones we have been showing here today. Furthermore, it allows you to download a free trial at any time whenever you are ready. Try this yourself. After installation, go to Example Models by clicking on Help, Examples. During this period, you have full technical support. You can ask questions. Just give us a call, use live chat, and send us email. Thank you very much for your attention. Now it's time for questions and answers. Is that if you can get the slides for it says Zhang, please send me an email to consulting@solver.com and I can send you the slides, or probably we go on our website. I am not sure. And then we do not have an option for precision tree, but we will have a simulation session and I will walk you through the simulation features and also our decision tree features. So, Mr. Venkata, if you send me an email, make sure you get invited to that simulation session, and then I'll show you what we can do with our decision tree features. Then we have one more question. How do I choose which bundle package to choose? So, best thing is depending on your model size. So let me go to our website and show you that most of this information is available on our website. Let me see if you can see the website now. So go to click on products page. The same information I gave you is available here. So depending on type of your application, you can see if you only have a optimization problem, you have a stochastic optimization, meaning your optimization problem includes uncertainty, then, or you are looking at the data mining product. So based on that, you choose a platform. If you only have a conventional optimization, then you can choose Premium Solver Platform or Premium Solver Pro products. Like what we use today, we use Premium Solver Platform. Then if you scroll down, there are a couple of PDF documents available that compare solvers for you. And if your size limits goes beyond the available size in the product, then you can have access to large scale engines that are only available in platform products. And if you have any further questions about those details, if you need, just email me consulting@solver.com, or you can contact our sales manager, Dwayne, at Dwayne@solver.com. Let me see if there's other questions. And if you need help deciding which is best for you, just email me and I can help you decide on that one. Great. So I don't see any further questions. Thank you very much. I really enjoyed presenting this webinar to you and trust that it was helpful to you. Just remember, you are welcome to send me any questions or comments to consulting@solver.com. And looking forward to future webinars with you. Thank you. We appreciate your time. Bye for now.